Hi everyone, this is Mr. King. We're going to finish up the sum and difference identities lesson. Now that we know the sum and difference identities, we can use them to verify additional identities. So let's look at an example. Let's say we want to verify the identity, the sign of x plus y plus the sign of x minus y is equal to 2 sine of x cosine of y. What we're going to do is we're going to use the first identity up here at the top, which is that the sine of a plus b is sine of a cosine b plus cosine a cosine of b. And we will replace x for a and y for b. So we'll take this first term right here and we'll rewrite it as sine of x cosine of y plus cosine of x sine of y. And then we'll turn to the sine of x minus y. And we'll use the second difference identity with sine, and that's going to give us a plus sine of x cosine of y minus a cosine of x sine of y. And what we're going to do here is we're going to try and move this left side of this equation to be identical, in fact, to the right side. And that will verify the identity if we can do that. So let's look at what we have here. Cosine of x sine of y occurs twice. And one of them is positive and one is negative. There's a difference. We can cancel those out. They eliminate each other. We're left with a sine of x cosine of y and a sine of x cosine of y. So we wind up with 2 sine of x cosine of y, which we recognize is exactly what the right side of that equation was. So we have verified that identity. Let's take a look at another example. In this case, we have 2 fractions on the left, 1 fraction on the right, and we can see that the denominators on the left, if we were to multiply those, we'd get a common denominator that would match the right side. So let's create common denominators on the left and then see if we can combine things. We'll need to use the sum and difference, well in this case the difference identities for sine and cosine in another step. So first of all, we'll multiply the first fraction here by cosine of b over cosine of b, and we'll get cosine of b sine of a minus b. That will be over cosine of b sine of b. And then we'll add to it the sine of b times cosine of a minus b. That's a terrible b. Do that again. Over sine of b cosine of b. There's our common denominator. In the next step, we're going to use the difference identities for sine and cosine. So we're going to replace this sine of a minus b here by sine of a cosine of b minus cosine of a sine of b. And the common denominator here is cosine of b sine of b. And we also have in front the cosine of b right here. So we'll put that back in. Probably should have written that first. Over here we're going to have the sine of b. Denominator sine of b, cosine of b. And then we're going to use the difference formula identity, that is, for cosine of a minus b. This one looks a little different. This one is going to say that we were going to write cosine of a cosine of b plus sine of a sine of b, like that. Now at this point, let's see if we have some things that cancel out, because sometimes that happens. Now remember, the denominator is the same. So what we can really do here is we can We can combine these under one denominator, and not so easy to do that with pencil and paper, but with a Surface computer it can be done, and a Smart Pen, or whatever you want to call it, Surface Pen. So anyway, let's see what we've got. There's a plus sign here, first of all. Cosine of b, sine of a, cosine of b. Do we see anything that looks like that? No. Cosine of b, cosine a, sine b, and it's negative. Cosine a, sine b, cosine b, and it's positive. So we have an elimination there. These two are opposites if we include the distributions. That's a way to speed up our work, by just looking at it and spotting that. And all that's left at this point is cosine of b, sine of a, cosine of b, plus sine of b, sine of a, and there's another sine of b there, isn't there? And so that's going to give us a sine squared b. And in fact, to the left here, we can see that we actually can simplify that. We can write that we have sine of a cosine squared b. And over here, we can change the order to sine of a sine squared b, like that. And then our denominator again is cosine of b. Well, I'll write it in the order that we see it on the right. Sine of b, cosine of b, like that. Now when we look what's going on in the numerator, we see that we have a common factor here, the sine of a. So we're going to pull that common factor out, sine of a, and inside the parentheses, when we do this factoring, we've got cosine squared b plus sine squared b, again over sine of b, cosine of b, and we see that this summation is the Pythagorean trig identity, that equals 1. And that leaves us with the sine of a over the sine of b cosine of b. And we're done. In our final example, we're going to look at a problem that's on page 690 in our text. And we're going to be finding function values and the quadrant of a plus b. And we're told some information about a and b. The sine of a is 4/5, and a is in quadrant 2 because it's between pi over 2 and pi, so that's quadrant 2. And the cosine of b is negative 5/13, and b is between pi and 3 pi over 2, which puts it in quadrant 3. First, find cosine of a and sine of b. And to do this, we're going to use the fact that we know that sine squared a plus cosine squared a is 1. And we know sine is 4/5, so we can substitute that in like this. And we get 4/5 squared plus cosine squared a is 1. 4/5 squared is 16 over 25. So we can quickly get to cosine squared a is 1 minus 16 over 25. And 16 over 25 from 1 leaves us with 9 over 25, since 1 is 25 over 25. Now from that we can figure out that the cosine of a, well, normally we would say the cosine of a is plus or minus 3/5. However, we know that angle A is in quadrant 2. And in quadrant 2, the cosine is definitely negative. So here's an important piece of information. The next thing we're going to do is we're going to find out what the sine of b is. And so similarly to what we did a moment ago, the sine squared of b plus the cosine squared of b is 1. But we know the cosine of b is negative 5/13, so I'm going to replace that. And that gets squared. That gives us sine squared b plus 25 over 169 is 1, which leads to sine squared b equaling, well, 1 is 169 over 169. And to get sine squared b by itself, we subtract 25 over 169 from each side, which is 144 over 169. We have a lot of nice perfect squares here, don't we? And this leads to the sine of b equaling plus or minus 12 over 13. However, we go back and we look and we see that angle A is in quadrant 2. Angle B is in quadrant 3. And in quadrant 3, the sine value is negative. And so sine of b is negative 12/13. We are now in a position to find out what sine of a plus b is. So sine of a plus b is sine of a, which we were given. Sine of a is 4/5. Cosine of b, which we were given, it's negative 5/13. Cosine of a, which we found, it's negative 3/5. And the sine of b, which we found, which is negative 12/13. So we can go ahead and simplify here. The 5's divide, and we get negative 4 over 13. But actually, in terms of getting a common denominator here so we can combine, I'm not going to divide the 5's. I will leave that as 5 times 13, which is 65, and then negative 20, 4 times negative 5. And then negative 3/5 times negative 12/13 will also give us 65 in the denominator, and 3 times 12 is 36. And when we combine 36 and negative 20, we see that our answer is 16 over 65. And that is the value of the sine of a plus b. Next, we're going to find out what the tangent of a plus b is. As we can see from our identity here, we're going to need the tangent of a, which is sine of a over cosine of a, and we'll need the tangent of b, which is sine of b over cosine of b. Well, the sine of a was given to us, and it's 4/5. So that's 4/5. And then the cosine of a we found earlier, and it's up here, it's negative 3/5. And that reduces to negative 4 over 3. Next we go to tangent of b. It's sine of b over cosine of b. Sine of b, we can find here, it's negative 12/13. And the cosine of b, was that given? Yes, negative 5/13. And this reduces to 12 over 5. Anyway, we now have the numbers we need to find out what the tangent of a plus b is. So at this point, we can plug in our numbers. So the tangent of a plus b now, it's going to be the tangent of a, which is negative 4/3, plus the tangent of b, which is 12/5, over 1 minus the product of negative 4/3 and 12/5. Let's simplify this. So to combine 4/3, the negative 4/3 and 12/5, we need 15 as a common denominator. And that means we're going to multiply 4/3 by 5 over 5. So that will give us a negative 20. And we multiply the 4 by the 5. And then we multiply 12/5 by 3 over 3. That will give us a 36 over 15. So that's the numerator. And then in the denominator, we have 1 and it's going to be plus 48 over 8. 4 times 12 is 48. 48 over 15, isn't it? 48 over 15, like that. So we can clean this up a bit. We've got 16 over 15 in the numerator, and 1 is 15 over 15. 15 and 48 is 63. So we get 63 over 15, and that will reduce, we divide the 15s, to 16 over 63, which is the value of the tangent of a plus b. Finally, we want to find out what quadrant a plus b is in. We know that the sine of a plus b is 16 over 65, which is greater than 0, which means a plus b could be in quadrants 1 and 2. We know that the tangent of a plus b is equal to 16 over 63, which is greater than 0. And that means a plus b could be in quadrants 1 or 4. And I should have said or up here for the sign as well. Now, I think when we look at this, it's pretty easy to see that the quadrant that occurs both times is quadrant 1. And so we conclude, therefore, a plus b is in quadrant 1.